In this video, you're going to practice or just see a couple of problems over everything that we've done. Simplifying expressions, solving equations, solving inequalities to help you prepare for your test on Thursday. Okay, so when we simplify expressions, you're going to notice there's no equal sign. So you just need to combine your like terms and combine them with the same sign. So you don't use opposite signs when you're simplifying. You use the exact same sign that's there. So starting from the left, I have negative x plus 6 plus 3x minus 15 minus 2. So I'm going to combine my negative 1x with this positive 3x. When I combine them, I use the exact same sign, and I only combine the numbers in front. I leave the variable alone. So negative 1 plus 3 is a positive 2x. Next, I'm going to take a positive 6, and I'm going to combine it with a negative 15 minus 2. When I combine those, I can go in order and take a positive 6, subtract 15, get negative 9, and then subtract 2, you'll get negative 11. Or you can say negative 15 minus 2 is negative 17, and then add that to positive 6, you still get negative 11. So here, when you combine constants, you use the sign that's there to combine them. So this should be a negative 11. And here, you cannot combine 2x and negative 11, so here you're done. 2x minus 11 is your final answer. Now we're going to simplify an expression that has a fraction. So we're going to take negative 3/4 parentheses 12 minus 8x and subtract 2. So the one thing you want to identify is the parentheses. Parentheses means that we need to multiply. We need to multiply negative 4/3 to each term inside the parentheses. We're not going to multiply anything with negative 2 because it's on the outside. So we're going to multiply and distribute negative 3/4 to 12 and negative 8x. So when I multiply, I'm going to show my work. I'm going to take negative 3/4 and I'm going to multiply it with a positive 12 over 1. Then I'm going to take that negative 3/4 again, and I'm going to multiply it with a negative 8x over 1. These are whole numbers over 1. I'm just going to bring that minus 2 down, and I'm not going to do anything with it just yet. Now I'm going to multiply these fractions straight across, numerator with numerator, denominator with denominator. Negative 3 times a positive 12 is a negative 36. 4 times 1 is 4. So negative 36 over 4. Then I'm going to take a negative 3 and I'm going to multiply it with a negative 8x. So I should get a positive, that's my sign, 24x. Now I need to take a positive 4 and multiply it with a positive 1. That negative is only to one term when you're dealing with a fraction. Now you take positive 4, multiply it with a 1. So you have negative 24x over 4. And then you can bring down that minus 2. Now we can simplify. If you had the calculator or you knew right away that negative 36 divided by positive 4 is a negative 9, you could have done that right away. I just want to show you the work on how we're going to get these values. So negative 36 divided by 4 is negative 9. Positive 24 divided by 4x is going to be a positive 6x. And now I still need to bring down this negative 2. So my last thing to look at is, are there any like terms? Because I distributed, now I need to make sure my work is cleaned up before I say I'm done. Well, I need to combine the like terms, which would be a negative 9 minus 2. So when I combine those, I should get a negative 11 plus 6x. And here's where I look at my answer, and I know I cannot combine those, so I'm done here. You're done simplifying. Okay, now we're going to move on to solving equations, and we have 3 types of problems for solving equations. So I'm going to start with the 5x plus 10 equals 6x minus 20. So first thing I want to do is move my variable. It doesn't matter which side you move your variable. You can move your variable to the left, you can move it to the right. It doesn't matter which way. I will just go ahead and move my variable to the right to see what happens. All right, if I'm going to move my 5x with positive 6x, that's going to keep my variable positive. So I would need to subtract 5x from each side, subtract 5x to keep my equation balanced. 5x minus 5x is 0. It goes away. I'm going to bring down my positive 10 equals 6x minus 5x is a 1x, so I just have to write x. Now I need to bring down this negative 20. My last step is to get rid of this negative 20. Because I moved my variables to the right, I need to move my numbers to the left. So I'm going to add 20 to itself so that it cancels and goes away. Add 20 to 10 because those are like terms. Now I just need to simplify from here. 10 plus 20 is 30 equals x. I do not need to divide by a positive 1 because anything divided by 1 is itself, so I know I'm done here. X is equal to 30, 30 is equal to x, exactly the same thing. Okay, so that's an example of one solution when you solve an equation. Now let's look at this example. We have 5 parentheses x plus 12 equals 7x plus 5x. 7 plus 5x, excuse me. When I see parentheses, I know I need to multiply, so I'm going to multiply 5 with x and 5 with positive 12. When I do that, I'm going to get 5 times x is 5x because there's a 1 in front. 5 times a positive 12 is a positive 60 equals 7 plus 5x. Now I'm to the point where I need to move my variables. Well, now I'm just going to look at this and I'm saying, okay, let's move this positive 5x with this other 5x. And the only way we can move it across the equal sign is by using the opposite sign. So I need to subtract 5x from each side, subtract 5x from each side. When I do that, 5x minus 5x is 0 and it goes away. So I'm going to bring down 60. 5x minus 5x is 0 and I'm left without any variables. So I'm going to bring down what I have. When I look at this answer, my answer isn't x equals 60 or x equals 7. When I read this, 60 equals 7. Is that true? No, that's not a true statement. That's a false statement. So anytime you cancel your variables and you're left with two values that are not equal, we say it's a no solution. There is no value for x that we can plug in to get us an even amount, or to find a value for x. Okay, our last example is going to be 6 parentheses x plus 3 equals 6x plus 18. Now I see parentheses, I'm going to distribute and multiply. So 6 times x is 6x, 6 times 3 is a positive 18, equals, everything on the right stays the same, 6x plus 18. When I look at this, I can automatically identify that I have the exact same numbers on each side of the equal sign. But let's go ahead and continue to solve because it may not be that easy sometimes. Let's move our variables to the left and we're going to move this 6x by subtracting it from both sides. When we subtract it from both sides, our 6x minus 6x goes away and it's 0. 6x minus 6x goes away and it's 0. Let's write down what we have left to see what happens. I will have 18 equals 18. Both of these values are positive. That's a true statement. Anytime you're left, your variables cancel out and you're left with a true statement, that is infinitely many solutions. So understand there's 3 types of equations you can see. Here we have one solution, no solution, or infinitely many. Notice the difference. Variables can cancel in both of them, but one, you get a false statement, no solution. The other, you get a true statement, infinitely many solutions. Okay, now we're going to look at solving inequalities. When we're solving inequalities, we have to remember that this symbol is no longer an equal sign. It's a greater than, less than, greater than or equal to, and so we have multiple things we need to do. We need to remember when we are multiplying or dividing by a negative, that symbol will flip. When we have our variable on the right, we need to rewrite our answer so that our variable's on the left. And we need to remember to graph, open or close circle, and which direction are we going to shade based on our answer. And also be able to answer your solution in words. Okay, so we have 3 parentheses x plus 2 minus 2x. So I'm going to look at the left side and distribute that 3. So again, there's always a 1 in front of the x if you don't see it. We're going to take 3 times x and 3 times 2. We don't multiply 3 with negative 2 because it's on the outside of the parentheses. You only multiply to what's inside. So 3 times 1x is 3x. 3 times positive 2 is a positive 6. Then I'm just going to bring down this minus 2x because we couldn't do anything with it. Bring down your symbol, and let's do the same thing on the right side. So now we have 4 parentheses x minus 3. That means I only distribute 4 to the terms inside the parentheses, x and a negative 3 or minus 3. This positive 6 will come straight down. So 4 times x is a 4x. 4 times a negative 3 is a negative 12. Again, bring down your sign with that value. Now, before I begin to solve and move my variables to one side, I need to clean up my work so that I have my like terms together. So I have 3x plus 6 minus 2x. I know that 3x and this minus 2x are like terms, and I can put them together. You can put them together with the exact same sign when they are on the same side. So I'm going to take 3x minus 2x, 1x. Then I'm going to bring down my plus 6. I keep my symbol. Here, when I look at this, I can't combine my x's, but I can combine these constants here. So I'm going to bring down my 4x, and then I'm going to take this operation and take negative 12 plus 6. Again, same side, same sign. So negative 12 plus 6 is a negative 6. Now I'm to the point where I can move my variables to one side and move my numbers to the other. So I'm going to move my variables. Let's just move our variables to the right so that you can get see what will happen if we end up with our variable on the right and how to rewrite that. You can move your variables to the left. You're just going to be dealing with the negative. So, let's just go ahead and move to the left so we can practice having our variables on the left. So let's move this positive 4x to the left. I'm going to subtract 4x here. I'm going to subtract 4x here. So when I subtract 4x from 1x, I'm going to get a negative 3x. I'm going to bring down this positive 6, bring down my symbol. 4x minus 4x is 0, it's gone. You must bring that number down with its sign, negative 6. Now that I move my variables to the left, I'm going to move my numbers to the right. I'm going to subtract 6 to get rid of it on the left, subtract 6 to get rid of it, or to move it over. So positive 6 minus 6 cancels and goes away. Bring down your negative 3x, bring down your symbol, nothing has changed. Negative 6 minus 6 is not 0. Please make sure we're checking this in our calculator. If we're trying to read this and go too fast, pay attention to the signs. Negative 6 minus 6 is a negative 12. Now I'm going to take this negative 3 in front of the x and divide by negative 3 because that's the opposite of multiplying negative 3 with x. Whatever I do to one side, I must do to the other. So divide by negative 3. Negative 3 divided by negative 3 is a positive 1x. But this is where that information change, or our symbol changes from a greater than to a less than because we divided by a negative. So negative 12 divided by negative 3 is a positive 4. This is going to be my final answer. You must flip your symbol when you divide by a negative. Always remember that. It's very important when you're dealing with inequalities to flip that symbol when you divide by a negative. And the last thing we're going to do is practice drawing this on a number line, graphing it, and writing it in words. So when I draw this on my number line, we don't always have to have 0 in the middle. I want to identify first, what kind of circle should I have based on my symbol? Well, my symbol's less than, so I should have an open circle. That means I'm not including that value. And if I'm talking about all the numbers less than 4, I should be shading all the numbers to the left of 4 because those are the values that are less than 4. And then I can identify, oh yeah, there's 3, there's 2, over here, 5, 6. So if you were asked in this question, is 4 a solution? No, 4 is not a solution. It's not included in my inequality. So no, it's not a solution. But if I was asked, is 3.5 a solution? Yes, that's less than 4. Is 6 a solution? No, that's greater than 4. So in words, you would say all real numbers less than 4. Okay, and then we're going to do 2 more examples of solving inequalities. Here they are. On the left, we have 3 parentheses, x minus 5. On the right, you have 2x, or we'll look at the left value first. So when I see parentheses, I know I need to multiply. So 3 times x is a 3x. 3 times negative 5 is a negative 15. Bring my symbol down, and then I bring down what's on the right. Now I need to move my variables to one side. Well, it would be easiest just to move my variables to the right because that's where the other term is. I'm going to subtract 3x from each side. So when I do that, 3x minus 3x is 0. I want to cancel it on one side. I'm going to bring down this negative 15. And then when I take 3x minus 3x, it's also 0. So I know we would just cancel this and have it go away, but we want to write 0 here so that we can look at this inequality and ask ourselves, is that true? Is negative 15 greater than 0? No, that's not true. That's a false statement. So when we have a false statement, we say no solution. There's no value for x that will make this inequality true. So you can't graph that because there is no solution, you cannot graph. So in this case, when our variables did cancel out, we were left with 2 numbers on each side of the inequality, and it was not a true statement. It was false, so it was no solution. Now I'm going to take 2 parentheses x minus 2 and distribute 2 times x and 2 times negative 2. 2 times x is 2x, 2 times negative 2 is negative 4. Bring down my symbol. Now I'm going to do the same thing on the right side. This time I have a negative 2 times 1 and a negative 2 times a negative 1x. So negative 2 times 1 is negative 2. Negative 2 times negative 1 is a positive 2x. So now again, I'm going to move my variables to one side. I'm going to move this positive 2x to the left by subtracting 2x, subtracting 2x. When I do that, both of my variables will cancel on each side, but I need to figure out what am I left with. Negative 4 is less than or equal to negative 2. Well, yeah, negative 4 is less than negative 2. That is a true statement. So when you're left with no variables, they cancel out, and you're left with a true statement, we say infinitely many solutions. Very similar to solving equations. Infinitely many solutions. So when you graph that on a number line, it's going to be all those values. You're going to be shading everything on that number line. Okay, I hope this video helps.